Dynamic analysis layer Linux.
Hi everyone, thanks for watching laurieWIRED, and in this video I'm going to show you some quick tips for your dynamic Linux malware analysis. So if you're trying to dynamically analyze Linux malware and you're actually trying to execute the sample to see what kind of behavior it has, you're going to definitely want first a dedicated, isolated malware analysis environment. So the couple options that you have for this, the first might be using a hypervisor such as Hyper-V or VMware and creating checkpoints before you're actually doing your dynamic analysis. The second might be using a cloud-based option where you have a virtual machine running in the cloud provider of your choice, such as Azure or AWS. But the most important thing to note is that you do not want to run the malware directly on your host system because you totally can infect yourself and have a lot of problems there. So you really want an isolated malware analysis environment that is entirely separated from your host. Now there's a lot of tutorials already out there that'll help you set up virtual machines for your dynamic Linux malware analysis. So what I'm going to do today is I'm going to show you how you can use Docker containers to speed up and streamline your malware analysis for Linux so you can pre-install tools or potentially create new containers if you're trying to repeatedly analyze a sample. So let's get right into it. I'm going to pull up my Docker container and I'm going to make this link available in the comments section of this video. And I'm just going to go through a little bit about what this does and how you can use it to get started with some of your Linux malware analysis. So the first thing is the couple use cases for this. First of all, if you're trying to dynamically analyze ransomware, for example, sometimes these check for different directories and will go through and encrypt your entire host. So you might want to be rerunning these samples multiple times to do different manipulation for the sample when you're trying to analyze it. If you're trying to debug it or use strace or something like that, you might want to be repeatedly running this. So this is where containers come really in handy because you can reset the state of these containers multiple times and just copy over the ransomware, encrypt the full drive of the container without actually affecting your host malware analysis machine so that you're not encrypting that host multiple times and having to reset the state every time you're trying to do your analysis. The second use case comes in if you're trying to bundle all of your preferred reverse engineering tools to a different machine. Maybe it's entirely new and you actually don't have any software installed. This way, you can actually put all of your tools inside of a container and automatically have those available if you're trying to switch malware analysis machines constantly. So let's go through and see some of the different software that is actually installed in this container. First of all, for how you're going to use this, I have a shell script that's already inside of here. All you need to do is run this and then pass in the arguments of the file names that you're trying to copy over to the container. This script is going to take these files, bundle them up, put them inside of the container so that you can analyze those target files or include any dependency files that you might need during your analysis. Down here, you'll find a lot of different commands that I find useful in my daily analysis of Linux malware, such as strace or gdb as your debugger, and you can use these inside of the container just as is, since they come pre-installed. So let's move on to the actual contents of the Dockerfile and shell scripts. First of all, you can feel free to make any edits of your choice if there's some software in here that you don't want to add that's just taking up space, or optionally, if you want to add some software in here that I did not include, feel free to make any of these changes. But this, by default, is going to be running on an Ubuntu container. It's going to install all of these different packages for you in your malware analysis, and then it's going to make the working directory /home/app. If you remember the arguments of the different file names that you're passing to that shell script, this is where all of those file names are going to end up when they're copied into the container. Now let's go over to our shell script and take a quick look at that before we try running it. And what this is going to do is it's going to take your file names, it's going to create a new Docker image if the image is not already created, and then you can spin up or kill containers based off of that image. It's going to take all of those files, tar them up, and then untar them once they're inside of the Docker container and get rid of that temporary tar file. And it's going to open up an interactive shell to the container once it's built so that you can run any of your standard Linux commands inside of that container. Then once you're done, all you need to do is enter the exit command, and this is going to kill and remove the container and completely reset your state. So any subsequent times you actually run this, you're getting an entirely clean container. Again, as I said, this is really useful if you're trying to constantly reset the state for ransomware and you don't want to bother using checkpoints. Now, if we go back to the root, just make sure you're aware that you already need to have your dedicated malware analysis machine on here. This is just to speed up and standardize your process, but there are many Docker escapes that exist in the wild, so you want to be careful and make sure that the machine that you're running on can be infected with malware if that malware has anything nasty inside of it that tries to escape. Now let's move on and let's just test running this and see what happens. So I'm going to pull up my dedicated Azure virtual machine. This is my malware analysis environment. And I already have all of my files installed on here. So if you take a look at my Dockerfile, this is just the same thing that's inside of the repository. Same goes for the Linux malware analysis shell script. This has all of the different script commands that you would want inside of here. I also already have an example malware file. This is a sample from the Black Basta Linux ransomware. So I'm just going to demonstrate running this shell script and adding that in and how this actually includes the file inside of the Docker container for my temporary malware analysis. So all I need to do is I need to just do /Linux malware analysis container.sh, and then I need to pass in the name of any files that I want copied into my container in this home app directory that you see specified right here. So I'm going to copy in this sample1 Black Basta, and it will take multiple arguments and just bundle all of those files in. And this is actually going to be running my container. Now, the very first time that you do this, it's going to have to build the image. And this may take a couple minutes to entirely build, but just know that once you've built it once and you're not making any other changes, the only time it will take that long to build is that initial first time. So any other times that you're running this, it's just going to be spinning up new containers from that base image that Docker has already built. So now I've actually opened up an interactive shell inside of my container. So I'm not running on my host Azure VM anymore. I'm running inside of this Docker container. So any bash commands that I send to this are going to be run inside of the container. And if I do ls inside of here, you can see it's already copied over the Black Basta ransomware sample that I specified as a command line argument, and it's also made it executable, so anything shell script or elf binary is automatically going to be made executable by this, and not any normal text files or anything like that. So if I go back to my options here in my GitHub repository, I'm just going to demonstrate a couple things that this is capable of. Let's look at the file command. If I do file, and then the sample name, this is just showing me different details about the binary. For example, it's a 64-bit binary. ELF stands for executable and linkable format, which is the main binary type for Linux applications. And let's look at some strings that are inside of this binary. So these are just common reverse engineering tasks that you might want to do if you're analyzing a file. So I'm going to do strings, and then the binary name, and then this prints all of the different strings that are found inside of this Linux binary inside of this ransomware. Now, if I'm trying to do some dynamic analysis, what I might want to do is run strace. So I'll just do strace, then the binary name. Oops, I need my /. And this is printing out all of the different system calls that are definitely really interesting if you're trying to reverse engineer or dynamically analyze malware. And then finally, if you're trying to run something inside of a debugger, there's GDB already installed on here. So I'm going to do GDB and then my sample name. And then this is just going to open up my debugger and connect to my specified sample where I can step through all the different instructions, look at memory, or anything like that. So I'm just going to exit out of here. Now, once I'm done with all of my analysis, all I need to do is just type exit, and it's going to close and remove the container. So I'm going to go exit, and it's closing out my interactive shell. And if I do docker ps or docker ps-all, then it shows that it's already gone through and actually killed and removed the container. So if I wanted to run this again and reanalyze the sample or pass in a new sample, all I would need to do is just run the shell script one more time and then pass in any file that I would like to analyze, and then I can run this again and look at any samples that I want to additionally analyze and look at the dynamic behavior of. So thanks so much for watching laurieWIRED, everyone. In this video, I showed you a quick way how you could use Docker containers to speed up or standardize some of your Linux malware analysis. This container comes pre-installed with a lot of different common reverse engineering tools, and you can feel free to add any software that you might want or make any changes to the Docker container if you would like to create any additional standardized mechanisms for your containers. This is also really useful if you're having to reanalyze the same sample over and over again, or potentially analyze multiple samples at once that you don't want constantly stepping on each other's toes. So you can reset the state of the containers and potentially reset any encrypted directories or anything like that, just over and over again while you perform your continued dynamic analysis. So thanks so much for watching laurieWIRED, everyone, and I'll catch you in the next video. Pro move to hold it is like this. Okay.
3, 2, 1, go!
We just got 2 buttons for this. Woo.